Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved the first 13 questions related with exercise number 7.5 related with chapter number 7 Trigonometry class 10 Mathematics. The exercise number 7.5 is totally related with prove the identities, the trigonometric identities. There are total 17 questions in this exercise, out of which 13 questions has already solved in the previous videos. In today's video, I am going to solve the last 4 questions of exercise number 7.5. Question number 14, 15, 16 and 17. So let's move toward question number 14. It tells that cos power 4b minus sin power 4b should be equal to 1 minus 2 sin square b. So let's suppose I take the side which is left hand side. So left hand side, on the left hand side, taking LHS, on the left hand side we have cos power 4b and minus sin power 4b. Now we can write cos power 4b minus sin power 4b in the form of cos square b whole square, because 2 multiplied 2 again gives us power 4, and minus time of sin b power 4 can be written as sin square b and whole square. Now let's suppose this is a and let's suppose this is b. So over here a formula is generated, a square minus b square formula, which is equal to a plus b into a minus b. So our a is cos square b, so it becomes cos square b and plus b. So b is sin square b, and after this a minus b. A is cos square b and minus time of b. B is actually sin square b. You know that cos square theta plus sin square theta gives us 1. If we replace theta with a, and if we replace theta with b, it doesn't affect the equation. It becomes sin square b plus cos square b will be 1. So sin square b plus cos square b gives us a value 1. And after this cos square b and minus time of sin square b. Now over here on the right hand side we have sin. So we will convert cos square b minus sin square b in the sin. So taking the given formula first, which can be written as sin square a plus cos square a, which is equal to 1. Now over here we have not a, we have b. So sin square b and plus cos square b. Now after this we can write it just like sin square b is equal to 1 minus cos square b, and we can also write it cos square b is equal to 1 minus sin square b. So over here I put in the value of cos square b, which is 1 minus sin square b. So it becomes 1 minus sin square b, and minus sin square b will come down as it is. So after this minus sin square b minus sin square b gives us negative 2 times of sin square b. So it becomes 1 minus 2 times of sin 1 minus 2 times of sin square b. So hence we proved 1 minus 2 sin square b, which is actually our right hand side of the given trigonometric equation. Now move to the next question, question number 15. Sin y plus cos y whole divided by sin y minus time of cos of y minus sin y whole divided by cos of y should be equal to secant y cosecant y. So it means that this side is actually a greater side and this is actually little side. So we can easily derive this little side from greater side. So it means that let's suppose I take left hand side. On the left hand side we have sin y plus cos of y divided by sin of y, and minus time of cos of y minus sin y and whole divided by cos of y. Now after this I take the LCM sin y and cos of y. So sin y and cos of y. So whole division. Over here if we multiply sin y into cos y, so that cos y will multiply with the numerator. So cos of y multiply with sin y plus cos of y. In the middle we have negative sign. Cos y multiply sin y will give us this sin y cos y. So multiply that sin y with cos of y minus sin y. So sin y into cos of y minus time of sin of y. Now multiply cos y with sin. It gives us sin y cos of y. And after this cos of y multiply cos of y gives us cos square y. Minus sin y cos y gives us minus sin y and cos of y. And minus minus will give us plus, and sin multiply sin will give us sin square y. So plus sin square y and whole divided by sin y and cos of y. Now after this sin y cos y cancel out with negative sin y cos y, and cos square y plus sin square y according to the property number first will be equal to 1. Just replace theta with y. So 1 divided by this term is get out cancelled because over here it is equal to 1. And they also cancelled, we are left with sin y cos y. Sin y and cos of y. Now 1 over sin is the reciprocal of cosecant, so it is equal to cosecant y, and you know that 1 over cos is the reciprocal of secant y. So hence we prove that this side is equal to secant y into cosecant y. Now move toward the question number 16 of secant x minus tangent x whole square should be equal to 1 minus sin x over 1 plus sin x. So let's suppose take a left hand side. Taking left hand side, on the left hand side we have secant x minus tangent x whole square. Over here let's suppose this is a, let's suppose this is b. So a minus b whole square formula. You know that a minus b whole square is equal to a square plus b square minus 2ab. So putting values in over here, so a is secant x, so secant x square, so it becomes secant square x. And after this plus sign, our b is tangent x, so it becomes tangent square x, and minus 2 times of a and b. A is secant x and b is tangent x, so a and b. Now after this, you know that this identity 1 plus tangent square theta is equal to secant square theta. Over here we have x variable, so just replace theta with x and the whole equation will become 1 plus tangent x plus tangent square x will be a secant square x. So put and replace secant square x with 1 plus tangent square x will become 1 plus tangent square x and plus tangent square x and minus 2 times of secant x and tangent x. Now after this it becomes 2 tangent square x, so 1 plus 2 tangent square x and minus 2 times of secant x and tangent x. Now after this 1 can be written as we can write it just like 1 plus 2 times of tangent x is sin x over cos x. So it becomes sin square x over cos square x because of square. So sin square x plus cos square x and minus 2 times of secant is 1 over cos x and tangent is sin x over cos of x. Now over here I replace 1 with cos square x over cos square x. Why? Because I make the denominator same in the whole expression. So the denominator over here cos square x and cos square x. So we can take the LCM cos square x. So in the numerator over here I left with cos square x and over here the LCM is cos square x. So in the numerator we have 2 sin square x. So plus 2 times of sin square x. And over cos square x is the LCM, so in numerator we have minus 2 sin x. So minus 2 times of sin x. Now after this, you know that over here cos square x plus 2 sin square x can be written as sin square x and plus sin square x. And over here we have cos square x. So this is equal to 1 and plus sin square x. So 1 plus sin square x and minus time of 2 sin x in the numerator, and whole divided by cos square x. Cos square x from according to this identity sin square theta shift on the right hand side. So cos square theta is 1 minus sin square theta and just replace theta with x. So cos square x will be 1 minus sin square x in the LCM. So 1 minus sin square x. Over here you formula a square, let's suppose a is sin x and b is 1. So a is sin x and a value of b is actually 1. So it is equal to a minus b whole square, because if we suppose a sin x and b negative 1, b is 1, so it goes a sin square x plus 1 and minus 2 times of sin x. So we can write it sin x minus 1 whole square in the numerator, and divided by 1 minus sin square x can be written as 1 plus sin x and 1 minus sin x. So according to the formula 1 plus sin x and 1 minus sin x. Now sin x minus 1 whole square can be written as sin x minus 1 and sin x minus 1. We just split it into 2. In the numerator we have 1 plus sin x, 1 plus sin x. From here if I supposed to be take out minus common, so minus time of I left with sin x and minus 1. Sin x and minus 1, because minus sin x and plus 1 again. Sin x minus 1 cancel out with 1 of the sin x minus 1 in the numerator. Over here the minus will move to the numerator, so it will multiply with negative 1 and sin x. So the sign of both of sin x and 1 will change because of this negative sign. So it become 1 and it become negative sin x, and in denominator we have 1 plus sin x. Hence we prove that on the right hand side we have 1 minus sin x over 1 plus sin x. Now move to the last question of exercise number 7.5 and the last question of today's lecture. 17 question tells that sin x into tangent x plus cos x should be equal to secant x. So now let's suppose I take the left hand side. On the left hand side we have a sin x multiply tangent x and plus cos of x. Now convert tangent x into sin over cos, so it becomes sin x multiply tangent x is sin x divided by cos of x, and over here we have plus cos of x. Now sin will multiply with sin, it will give us sin square x in the numerator. In the denominator we have cos of x and plus cos of x. Over here I multiply cos of x and also multiply in the numerator in the denominator. They can't affect each other, they cancel out, again we are left with cos of x. Now the LCM is same. So I take the LCM cos x. Over here I left with sine square x. And over here the LCM is cos x. So in numerator we have cos multiply cos gives us plus cos of cos square x. Now according to the first identity, sin square x plus cos square x should be equal to 1. So 1 divided by cos of x, and you know that cos x is the reciprocal of secant x. So on the right hand side we have secant x, hence we prove. So with this question I finished my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about questions mathematics, FSC part 2 mathematics or class 10 mathematics. Thank you.